Hello and welcome to episode 83 of our SAP on Azure video podcast. Today is March 10th, and together with Robert and Goran, we are here to talk about anything related to SAP and Microsoft. Hello, everyone.
Hi.
So after last week's SAP on Azure related topic, we want to look today at an SAP and Microsoft topic. So when integrating SAP with Microsoft services, there is one thing that has to be there to provide users with a good experience, and that is single sign-on. So today we have Martin Räpple and Will Eastbury back on the show, and they will talk about part 5 of Martin's Principal Propagation blog post series. This time, Azure API Management is introduced and acts as a bridge from the Power Platform to the on-premises SAP system. But as always, before we hand over to Martin and Will, let's actually quickly take a look at some of the blog posts from this week. And I want to start with our usual suspect, Martin Pankraz, who created another blog post about using logic apps to detect faulty states in your CPI, in your cloud platform integration services, iFlows. So it's another cool scenario where we look at what you can actually do with logic apps. So in this scenario, he has a logic app that runs on a regular schedule. He's then using HTTP calls to query the logs on the cloud platform integration side here, and then he collects this information, and then he can also raise alerts via Teams or Outlook. So it's a very simple flow, but I think it can be hugely impactful if you immediately get notified of if something is going wrong. And again, it's very easy to set up. And as always with Martin, you have all the documentation in here. There's a GitHub repository, so you can immediately get started and replicate this scenario also with your own logic app instance. Then Carlos Roggans has created has published another blog post. So we talked about his setup with OAuth 2.0 last time as well. There was one scenario where he really showed how to use OAuth on the business technology platform with the identity authentication service. And in the first blog post, he was using really all the calls one by one. He was really going through the whole authentication flow. Now he's using the destination services, which obviously simplify some of the steps that he needed to do before. Now he's using the destination services for the appropriate OAuth flow. And similar like last time, it's a very detailed blog post that really down here are all the code snippets that you can really also replicate this scenario and try it out on your own. But I think if you want to get a closer look at how OAuth 2.0 works on the business technology platform, I think these two parts that Carlos has published so far are really very, very helpful. Then one last blog post that I want, or not actually a blog post, but here really an entry on the SAP community, is this page here that talks about the Cloud Appliance Library. And as we mentioned some time ago, the Cloud Appliance Library now enables you to also deploy production-ready systems to Azure. So if you log on to cal.sap.com, you can see that there's now also an entry for deploying productive S/4HANA systems. So they adhere to the recommendations from Microsoft, from SAP when it comes to how to deploy an SAP system. So you can see here a landscape overview. And this is basically here now the landing page for all the topics around the production deployment scenarios. Okay, that was already all for this week, which I think is actually really great because now we can already switch over to Martin and Will, who will talk about the principal propagation flow. But Martin, Will, before you dive into the topic, maybe you can quickly introduce yourself. What are you doing at Microsoft? And and then I'm really looking forward to the presentation and demo that you have prepared.
Thank you, Holger. Let me quickly start. My name is Martin Räpple. I'm actually now the third time in your great podcast video series, right? So First of all, thanks again for the invitation.
Thanks for coming.
And Goran. So always enjoy it. Yeah, so I'm in a role of a cloud solution architect at Microsoft. And I'm closely working most of my time with SAP as our customer, helping them on their adventures on Azure. I have a special focus on identity and access management, and that's probably also the reason why I'm going to talk today together with Will about, again, a security-related topic, actually the continuation of a scenario that I presented already in 2 iterations in 2 of the last episodes. So next, Will.
Just wait for the team to come off.
Yes.
So, hi, I'm Will Eastbury, one of the principal engineers in the fast track for Azure EMEA team. My job in general on here will be to explain some of the concepts behind APIM in a little bit more detail, as that's what we're doing day to day as we work with SAP users.
Perfect. Thank you.
All right. Then I think it's up to me to share my screen. Let me see, and then we can jump into the topic. I probably would like to start with setting a little bit context and give you a short recap of what we have shown in the last episodes of this video podcast, and also give you again a little bit of a recap of the scenario of my blog post series, so that we are well prepared to jump into the actual topic for today, which is again a continuation, as I mentioned before, about the scenario for principal propagation in a multi-cloud solution that spans Microsoft Azure and SAP Cloud Platform or Business Technology Platform. Today we are going to focus on API management and Azure Arc, and why this is so important also in this scenario. This is what I'm going to hopefully motivate in the next few slides. But before we go into these topics, let me quickly recap the end-to-end scenario from a user's perspective that we are going to look at today. Essentially, it's quite simple. So I, as a user, as an end user, I'm logging into Teams, and I want to buy some new office equipment, and as a very convenient way that's enabled by my company, I can do so by chatting with a chatbot in Teams that should support me or help me in finding out the set of products that I can order for office equipment, and telling me about the price of them, and maybe even then ordering them through this chatbot. Yeah, so that's the user experience. The actual product data of this office equipment is stored in an SAP system in the backend, and I, as an end user, only have the permissions to buy certain categories of office equipment or products from that product catalog. For that reason, it's important that the actual search that this chat allows me to do in this product catalog in the backend system is based on my user's permissions in that backend system. Which means that I somehow have to authenticate with my user also to the backend system to execute this search operation in that product catalog. Certainly, I do not want to, as a user, being asked twice for any credentials in the backend system. The best user experience would simply be a complete end-to-end single sign-on experience that actually starts with Teams. Yeah, so I am logging into Teams, probably using my Azure AD authentication, or actually in a corporate environment with my Active Directory authentication. That single signs on me to Azure Active Directory, which then signs me on to Teams without any further asking for any credentials. And also the login to the chatbot should also certainly be supported with a single sign-on experience. This is something that we already talked about in the last episodes. And I've also shown in the last episodes how to propagate this logged in user in Teams, so in the chatbot, all the way to the SAP backend system, so that after step 1 is done, so the login into the chatbot in the chatbot, which is supporting already single sign-on through Teams. The actual query to the backend system also ensures that this logged-in user is silently propagated securely to the backend system, is mapped to my known user in the backend system, and the query is done with all the permissions of that user in the backend system, so that the response of the chatbot only contains product where I am authorized or allowed to access, such as here, for example, desk lamps. So that's the end-to-end flow that we want to take a look at also today. And as I said before, so in episodes 31 and 40 of this great video podcast series, we've already taken a look into the implementation of this end-to-end flow. So we looked in episode 31, we took a look at how this chatbot can make use of the bot framework SDK to implement the single sign-on with Teams, and then make a token exchange using Azure AD to obtain a token from the SAP side, and then use SAP BTP, the Business Technology Platform Integration Suite, as a means to integrate with the backend system using the SAP Cloud Connector and invoking finally a core data service or an OData service implemented with the CDS view on the backend system. In episode 40, we exchanged a little bit the technology. So we switched from this more pro code approach using the bot framework SDK. We switched to a Power Platform and also replaced and used here Power Virtual Agents as a technology or implementation alternative to the bot framework SDK. And we also replaced in episode 40 the integration suite on BTP with Power Automate, essentially. So and also replaced the SAP Cloud Connector with the on-premises data gateway. So episode 40 essentially provides an alternative approach using more Microsoft technologies for the integration side of this scenario. Nevertheless, what stays the same is certainly the backend that exposes this product catalog data using a core data service view on with an OData service, and also the client stays the same. It remains Teams that provides the runtime for this chatbot. Both of these episodes are also linked here with the corresponding blog posts on the SAP Community Network. So those provide a detailed step-by-step tutorial to follow to implement those scenarios. Now, let me quickly recap that last state that we presented in episode 40 of the solution architecture. So again, what we did here, we replaced the integration layer and the implementation technology of the chatbot from BTP Integration Suite and the bot framework SDK to Power Platform, essentially. So the bot is implemented using Power Virtual Agent as more like a low-code approach to implement chatbots, and the integration logic, for example, the flow to exchange the token obtained from Azure AD to a SAML assertion, and then using that SAML assertion to obtain an OAuth access token from the backend, from the SAP backend. All of that is implemented using a Power Automate flow. And the final call to the backend service, to this product catalog service, is also implemented in another separate Power Automate flow. So essentially, the flow in episode 40 was like the user invokes that chatbot. So he starts Teams. He or she is already logged in Microsoft Teams. Invokes this chatbot using a trigger phrase such as purchase new office equipment, for example, that triggers the invocation of that product search bot implemented using Power Virtual Agents. The chatbot now needs to obtain an access token from Azure AD, but it can do so using the already established authentication of the user in the Microsoft Teams application. Could be either the desktop application or the web application. That issues finally silently a fresh token to the chatbot that is issued to that user. Yeah, so the user is single signed on to the chatbot in Teams. And after that, the chatbot triggers this token exchange flow that is required to finally propagate the authenticated user end-to-end to the backend system. So once again, a quick recap of that flow. So what this exchange token flow in Power Automate does, triggered by the chatbot, it takes that OAuth access token issued by Azure AD to the chatbot and exchanges that with the help of Azure Active Directory into a SAML assertion. Why? Because only that SAML assertion can be sent to the SAP backend system in order to obtain from that SAP backend system, which runs the gateway component and which includes also an OAuth server on the backend system. The SAML assertion can be used to obtain an OAuth access token from the SAP backend system that can finally be used by that second flow here, the call OData flow, to invoke that product search operation on the backend. So that step number 4 is super important for this whole exercise here, because it provides that mandatory required token exchange from a OAuth JOT token into a SAML assertion. Yeah. So once again, that Azure AD issued JOT token, JWT token, JOT token can't be used as is and be sent to the SAP system. The SAP system will reject it because it has not been issued by itself. So it needs that SAML assertion, and that SAML assertion allows us to obtain an OAuth access token from the backend system, and that's done in step number 5. So with that SAML assertion returned in step number 4, this exchange token flow takes that SAML assertion and sends it via the secure tunnel established by the on-premises data gateway connection all the way directly to the SAP backend system. Here, the OAuth server component, which is part of the gateway deployment here of that backend system, then understands and trusts that SAML assertion. That certainly requires beforehand a trust relationship that needs to be established here. And after that, the user is certainly also the user is verified. That is identified by the SAML assertion. It must be possible to map that user, for example, using the email address in that SAML assertion, and map that to a known user in the backend system. So if, for example, we are using in this example here an email address of the user, jdo@contoso.com, that email address is also known to the backend system. However, the user in the backend system has a different login name, jdo, as in Azure AD. So therefore, some common denominator like an email address, for example, must be used to map the user from Azure AD to the backend system. If all of that goes fine, then the backend system sends back a fresh OAuth access token issued by the backend system back to the Power Automate flow, which is then taken in the next flow here to finally send the actual product search operation to authorize that request to the backend system. The backend system will ensure that this search operation runs only under the permissions of that logged in user that initially logged in here in Teams and has been propagated with this mechanism all the way to the backend system. So that search operation will only return products from the product catalog the user has access to, and then finally shows those products based on the search term that the user entered in the product search bot to the user. Okay. Now, after we have set the stage, let us, so I've worked with quite a number of customers on such a scenario or on similar scenarios, not necessarily using a chatbot, but many of our joint customers and mutual customers of Microsoft and SAP require such an end-to-end principal propagation, usually also starting with the user authenticated against Azure Active Directory, but then having the need to propagate that user all the way to the backend. However, all of those customers are typically very concerned when it comes to opening or exposing their backend systems for such scenarios, such as the one shown here, where essentially even through a secure tunnel and shielded by this on-premise data gateway, the endpoints here in the end are accessible by a client, in this case here, these Power Automate flows, because they are, for example, concerned of potential overload situations. Yeah. So, for example, they are concerned that there might be too many requests hitting that backend system. And this might not even be based on some sort of malicious denial of service attack. This might even come through, for example, a not known or steadily growing number of API clients out there that may not be under full governance and control of the backend here. And over the time, the load increases and increases, and at some point in time, that may really affect the productive status here of that backend system. Yeah. So in other words, any question?
No, sorry, I just wanted to say the Power Virtual Agent is so successful that more and more users are using it, and then the number of API calls to the backend increases. Exactly.
Yes. So they're simply pressing refresh all the time.
Yeah. Yes. Right. So, I mean, actually, usually, but Holger, you are right. I mean, usually this gives, so if a first scenario runs successful, then many other LOBs at our customers, line of business, then also look at these scenarios and say, hey, wow, this is a cool technology. And I have like 1,000 other scenarios in mind that could also benefit from this type of integration. Yeah. But then what they typically do is like they reuse, which is perfectly fine. Yeah. They reuse this in this, let's stick to this picture here. Yeah. They reuse this established infrastructure with the on-premises data gateway and the and this already exposed APIs on the backend as shared service. Yeah. To access also the data here on this. And that's perfectly fine, to make use or to see such components like this on-premises data gateway, or alternatively the SAP Cloud Connector, as a truly shared service, and certainly make sure that this is highly available, etc., because it essentially means a single point of failure also in this whole setup, but still more security and more control and governance around this type of access hits a really great demand, let's say, on customers that you talk about in these type of scenarios. And that brings me now actually to the topic of today's session, which is like, so what do customers ask me here when we started to implement such scenarios? So first of all, they were concerned about these already mentioned potential overload situations, right? They want to set sort of rate limits, to control the number of these requests hitting the backend services. They may also see the need to filter or block certain IP ranges. I mean, certainly, if we go quickly back to the picture here, there's certainly also a firewall in front of this, all of this. So this is not really explicitly shown here, but any customer has a maybe not even one level, but maybe a few levels of firewalls, in front of such, and they typically can provide such an IP filtering, But nevertheless, this might also change dynamically, and as we all know, changing firewall rules is something that typically takes, especially at large established customers like that have established infrastructure, days, even years, So you may want to be a little bit more flexible here, for example, in blocking access based on IP address ranges. You may also want to improve performance by not always asking or directing all the requests really down to the backend system, but maybe improve the performance by introducing some sort of caching that allows to send the response from a cache that sits in front of the backend system to reduce the overall latency of this scenario. You may also do not want the backend system to do all the validation, you may want to pre-validate certain requests in the header and want to offload all of this pre-validation to a layer in front of the backend system. Yeah. Also, changes in the backend system should not directly have an impact on the API consumer. So some level of indirection between the backend system and all the consumers that are out there is also highly demanded by architects that you talk about here, yeah, about this scenario. And finally, and also maybe even most important for day-to-day operations, is monitoring and alerting. Yeah, so get informed and know even in advance if a potential overload situation, for example, may occur. Okay, so all of that leads to the idea of introducing another layer here in that architecture or in that solution architecture, and that typically is provided by a component we all know about, which is called API management. Yeah, so API management exactly addresses all of these items that were listed in the previous slide, and certainly in this podcast, I want to talk about using Azure API Management here as a potential candidate here for introducing API management in such a scenario. So let me quickly talk about API management, and Will, please jump in if I'm saying anything wrong. I hope not. So from a very high level, Azure API Management consists of 3 components: a management plane, a runtime component, also called the gateway, and a developer portal. So the management plane is actually the place where you define and where you define the APIs that you want to manage with API management. Yeah, so that's typically, for example, the Azure portal. Certainly, there's also REST API to access this management plane, but typically, as an administrator, you access this management plane in the Azure portal, and this is the place where you start creating an instance of the API management service and then start defining your APIs. The gateway component is the actual enforcement or runtime component. So whatever you define in the management plane gets synchronized to that runtime component, and by default, that runtime component is also deployed on Azure. Yeah, so the default setup is like you have some services deployed on Azure that you want to shield or protect with an API management layer in front of it. So you would deploy an API management layer and a gateway component in front of these services that you want to expose to your API consumers, and yeah, essentially that's kind of the default approach here. And last but not least, the developer portal here is a place, for example, to provide discovery of APIs, yeah, essentially for non-administrative, so the main persona here is the developer that is targeted by this portal. Now, the interesting part of this gateway component is that it can also be deployed in with different options, and that comes with the so-called self-hosted gateway. So essentially, that gateway component is also provided as a containerized application that you can take out of Azure and deploy it to some other place. So that other place could be another cloud platform, yeah, where you may also have some services that and where you want the enforcement of your API management and rules, like the policies that you define in the management plane that enforce certain rules like rate limits, like blocking IP addresses, etc. And if all of this enforcement should occur close to the service that you want to expose with your API management, yeah, then you can take that gateway component as a containerized application, deploy it to an infrastructure that's provided by this other cloud platform as a containerized application, and use it there close to the source of to the backend of your APIs to enforce all of the policies and rules that you define in the API management plane. And the nice thing about this deployment option is that with the self-hosted gateway, it's only the runtime component that's distributed, but you still keep a central governance using the management plane in Azure to essentially configure all of the gateways that are distributed, maybe, for example, to other cloud platforms, like in this example.
So that would be a kind of preparation before moving to Azure.
Yes, exactly.
Yeah, so I think especially, for example, if I have a scenario where I have an API management, maybe only internal, where I want to protect my SAP system. If I'm still on premises, purely on premise, for example, and I want to offer an API management strategy for my internal on-premise colleagues or something like that.
Excellent question, Holger.
And also, I think one of the nice examples why Azure API Manager is very interesting is that many customers have custom applications which are, of course, using backend systems, but also using some third-party APIs. And they always need to provide some kind of layer of integration, which is very difficult to maintain. So now they can remove that layer of integration to API management, and there synchronize those calls for different sources, not just API, SAP, just also non-SAP. They can use the single sign-on, not just for SAP, also for other third-party sources, and unify that in one place. Yeah, and I think this is big value because this is giving a customer opportunity to really have one plane, management plane where it can really synchronize everything. Apply policies, security, and everything what Martin mentioned. I think this is very, very important, not just for SAP, also for some third-party integrations. Yeah?
Absolutely.
Yeah, it's actually not uncommon to see people create an entire facade of API across their entire environment, be that internal or external, and route traffic through either an internal or self-hosted gateway or out through a public gateway. And adaptively switch inside APIM to choose which targeted service you use, but depending on where you are, to present a unified API service across all of your backends, regardless of whether they're cloud hosted, on-premise, or wherever they are.
One question for this self-hosting gateway. Can I say this can be my edge scenarios where I can maybe cache some call and optimize my, IoT thinking?
I think
you can. As to how much you'd put inside that cache would depend on where you wanted to cache.
Okay.
There are features within API management to do caching natively. They're very simple to implement as well, cache policies. Obviously, depending on what you're running inside is going to depend on what cache you have available to you to use. But APIM will also support an offloaded cache. So you can actually have a Redis instance sitting somewhere for a shared cache across all of those scenarios. If you run a self-hosted instance, you're going to have an internal only cache.
And maybe coming back to Holger's question, so this like if I want to make use of Azure API management to protect on-prem backend systems, like in our scenario, if you remember, this product catalog is a service exposed by my on-prem backend system. I can certainly do exactly the same. Like I can take this self-hosted gateway, deploy it either as a Docker container or on a Kubernetes cluster as two options for deploying that containerized gateway in front of my backend system, and treat it essentially the same as if it would run on Azure or in another cloud or wherever. And I've heard from some customers really that this is a super important scenario and feature, because for some of these APIs, maybe not for all of them governed by the self-hosted gateway deployed here in the corporate network, but maybe by some of them, there might be really some very strict confidentiality requirements or security requirements that should prevent that any traffic will leave outside the corporate network. But still, you want to enforce that and want to be in a central governance or under central governance here with the management plane still remaining centrally on Azure to manage the self-hosted gateway, but essentially traffic in such an internal API consumer scenario will actually never leave the corporate boundaries, and in highly regulated environments, such as financial services, for example, you really may come across such a requirement, that for compliance reasons you need to really ensure that for some scenarios this is ensured, and self-hosted gateway can help you to do so. So
it's actually possible to deploy a self-hosted gateway with no inbound connectivity from the internet at all. In fact, one of the primary use cases.
Okay.
Yeah, we only mandate you need to have outbound connectivity on port 443 for the gateway to be able to call home and download its configuration.
Yeah, for the sync. Yes. Yeah.
But
So
this means
basically, no need
that
to
can
open
also
any kind of firewalls, right? Because it's outbound.
It's only outbound, yes.
Yeah.
It's like the on-prem.
Basically, everybody would have
cloud connector, like all the other very similar.
18443 would be always going outside. Yeah.
Yeah.
Will, you mentioned that you just need to the download configuration. Does that mean that I can have also from time to time switch off, so no internet connection at all for my own premise? You know, occasionally connected scenarios.
Yeah, they will cache configuration.
Okay.
So that's not its primary use case, because then you wouldn't be able to download any updates to configurations.
Yeah. Okay. Yeah. Of course.
Like, it will work. It has to work if it's an intermittent connectivity scenario. So it will cache until the connection is available. So it won't just drop if you lose outbound internet connections. But if it crashes for any reason and has to restart, then you'll need outbound connectivity.
Yeah, of course. Yeah.
Okay, so I think this just summarizes what we already mentioned now a few times, right? So only outgoing connectivity required on port 443, so TLS. It can be deployed on as a single Docker container, but also on Kubernetes cluster. And actually, that's also what we are going to use in this option, to deploy it on a Kubernetes cluster in the upcoming demo. Now, certainly the run. Yes.
Just before we continue on that slide, there's one point which is relevant because it pertains to what Robert just mentioned. It says functionally equivalent to the managed gateway. In terms of policy access, it is functionally equivalent. There are some keys, and these are well documented upon our docs page, that behave slightly differently inside the self-hosted gateway, and one of those, as Robert alluded to, is caching. So if you want to run caching policies to do localized caching using the self-hosted gateway, you have to use an external cache.
Okay. All right. Now, certainly the underlying runtime of the self-hosted gateway also becomes similar to the for example, to the on-premise data gateway, or the cloud connector from SAP becomes also a critical piece in this whole end-to-end flow, because if the underlying runtime dies, or runs out of resources or whatever, gets slowed down for whatever reasons, then certainly also any traffic or communication, because it's centrally flowing through that API management gateway, will certainly be blocked or not longer reaching the backend. And for that reason, it's also quite important to have, let's say, good control and monitoring of the underlying infrastructure where the self-hosted gateway is deployed to in this on-premise deployment option. And certainly Kubernetes provides very good means here to automatically scale, for example, such a deployment of the self-hosted gateway. It can even ensure almost zero downtime if an upgrade of the self-hosted gateway version, for example, occurs, etc., etc. Yeah, so Kubernetes certainly here is probably a good home, let's say, for the self-hosted gateway. However, you still, in those type of hybrid scenarios where you have part of the infrastructure for your cloud end-to-end scenario runs on premise and part of the infrastructure runs in the cloud, you certainly want to still also have, similar to this API management plane, some central place to control and to monitor all of the involved infrastructure components, including this Kubernetes cluster on-prem where the self-hosted gateway, API gateway is deployed to. And here comes Azure Arc into play. So Azure Arc is like on a very high level a way that allows you to manage and operate your infrastructure from the central management plane in Microsoft Azure. So it's the place where you can, like, where those resources, for example, Azure Arc enabled servers that run on-premise, or as in this example here, a Kubernetes cluster on-prem, it will appear next to other Azure resources in the portal, and from there you can apply all of the, or not all of the, but many of the services such as Azure Monitor or Azure Policy or Azure Defender for Cloud, and apply those controls on these infrastructure components, although they are not running on Azure, but for example in your own data center, or even in another cloud, or on the edge on some, for example, Azure Stack Edge, or any sort of device that runs those components on a factory floor, for example, or whatever. Yeah. So Azure Arc also helps us here to finally get to a more production-ready state of our scenario. Yeah, and so we will exactly look in the context of the self-hosted gateway deployed on an on-prem Kubernetes cluster that is Azure Arc enabled, so that we can also monitor and control the underlying infrastructure, the Kubernetes cluster, with Microsoft Azure. So that brings us then to finally this picture where I have highlighted the new components. So this is essentially the same solution architecture from the previous episode, but now added with two components. The first component is the API management. So we have to create a central or an instance of the API management in our subscription, from where we have the central management plane to define the APIs, to define the policies that we want to enforce on the API gateway, etc., etc. And we also have the runtime component on the right side of that picture, which is this Azure Arc enabled Kubernetes cluster that hosts the API self-hosted gateway, and that sits right between the on-premises data gateway that still exists and still continues to serve a very important purpose. That is the secure tunnel and the secure outbound connection or actually bidirectional flow from the Power Platform to the on-premises corporate network. But now all of the calls that went through the on-premises data gateway first hit the self-hosted API management gateway running on that Arc-enabled Kubernetes cluster. Any sort of policies defined centrally in Azure Arc are enforced here before the actual call hits the backend system. And with that solution in place, we can fulfill those requirements stated earlier in the previous slide, that customers certainly have when they are concerned about exposing their backend systems to potentially unknown number of API consumers, and maybe hit situations such as an overload situation. And with such a solution in place, certainly then you can also apply Azure Monitor, for example, on that Kubernetes cluster. You can also apply alerting rules on the number of requests that are sent to the API gateway here in order to, for example, react to an unusual high number of requests. And we are also going to show that in a minute in the demo. Okay. All right. So with that, let's go to the demo.
Perfect.
Maybe.
These are the on-premises Kubernetes cluster.
Yeah, so let's first take a look at the on-premises Kubernetes cluster. And I haven't deployed, unfortunately I don't have a server farm under my desk here. So for that reason, I just really simply made use of Docker Desktop, which fortunately gives us the opportunity. I don't know since which version it is, but you can simply enable a single node Kubernetes cluster locally on your desktop. On my, it's a 16 gigabyte laptop that I'm using, but it works perfectly. So you just have to click that button and then you have an on-prem Kubernetes cluster. I have deployed the API management gateway, the self-hosted gateway on that cluster. So let me quickly go to my to my API management instance on Azure. And let's take a look at the gateways that I have deployed. Here we can see that there is one gateway deployed so far. It's deployed on my Docker desktop Kubernetes cluster. And it also has a live, or there are regular heartbeats sent by this self-hosted gateway. So we see it's live. Yeah, it runs on one of the nodes in that cluster, and it basically tells me also here some metrics such as the number of gateways, the requests, etc. Yeah. So with that, let me quickly go to my Power Virtual agents. So maybe let's first quickly just go through the scenario end to end so that we see from an end user perspective, nothing really changes. Yeah, any questions in between?
Oh, sorry, go ahead. Yeah.
Okay, so let's quickly go to Teams as a client. So we won't use here in Power Virtual Agents the chatbot, this test bot here, but we are going to use the Teams, the web app in Teams. So let me quickly go here to my, let's open the bot. All right. Okay, so I'm already signed on to with my user to Teams. Yeah, so I've invoked now this product search bot here, and as you can see in a minute, I'm now, and nothing changes here from the previous scenario. So I'm essentially single signed on. So I now need to trigger the chatbot first, yeah, with one of the trigger sentences. So one of them is like purchase new equipment. And if I ask the chatbot here to help me here, so the chatbot welcomes me and single signs on me to the chatbot. So I don't have to, again, go through an authentication step here. And now the chatbot asks me which products I'm looking for. So now, since I am assigned only to the product category of cups and mugs, so I can only order cups and mugs, and I know the abbreviation, which is CM in the product name. So I'm looking for cups and mugs. If I would search, for example, for desktop lamps, which is DL, I wouldn't get any results. We can showcase that, but I hope you believe me because we showed that already on one of the last episodes. Yes. So let's search for cups and mugs. I know that it's CM is in the product name of these products in the product catalog, and now the chatbot starts this token exchange. It invokes the Power Automate flows to exchange the token, and finally then obtains the access token from the backend system, and and hopefully sends me a list of products that I can order and where I have some information about the price here. Right, so it also prints out. I mean, this is something you shouldn't do in a productive scenario. I will tell you in a minute why I'm printing out here the access token actually issued by the so that's already the access token issued by the SAP backend system. As I said, you certainly shouldn't do so in a real productive scenario, but we make use of this token in a minute to simulate an overload scenario. So that I can demonstrate that the API management kicks in now. And yeah, okay, it takes some time, maybe because the fact is that I'm also running this SAP system here on my laptop. So quite a huge load. So I'm running here, by the way, can highly recommend this if you want to have like a local development experience with an SAP system. Try out this Docker image of the ABAP trial system. It's really very easy to install, and yeah, so quite.
But it needs a lot of resources.
Oh, it takes, yeah. So I haven't invoked it now. So let me, okay, I mean, you can see here. Okay, maybe let's give it a second. But in the meantime, I would like to show you the API management. So these are the logs of my self-hosted API management gateway on that Kubernetes cluster. So you can simply use the common CLI tools like kubectl with that Docker desktop Kubernetes cluster, and then, for example, print out the logs of a specific pod that runs or hosts the API management gateway. And I've just done so here, and then it sends out or it prints out the logs. And let me go down here. As you can see, the first request that went through the okay, obviously I've got a timeout. The operation was cancelled. Okay, connection failure. Okay, let me. But the first request actually went fine because we already saw the token, and as you can see, that request was just from that resulted here in the chatbot here in that printout of the access token to the backend system. It went actually to the endpoint exposed internally in my corporate network by the API management gateway. And it actually then went all the way down to the backend system to request that access token using that SAML assertion that previously has been asked or requested by the Power Automate flow from Azure AD. Yeah. So maybe let me quickly repeat that. But nevertheless, let's take this token quickly and copy and paste that into a load tool to simulate an overload situation and see how that will be enforced and blocked by the API management gateway. So for that purpose, I'm using JMeter. Let me again search for cups and mugs. Let me use JMeter here. So JMeter is a nice tool to simulate kind of a load testing scenario. Certainly also this tool directly invokes also this endpoint exposed by the by my self-hosted gateway on the Kubernetes cluster. So it essentially invokes the same API or the same endpoint as the on-premise data gateway does in our scenario. It is configured to run like 20 parallel threads. So within like a second or two, it will hit the API management gateway with like 20 requests. Yeah? And I have configured a policy, and let us maybe also quickly take a look at that policy. Of my exposed APIs that should rate the limit of the calls so that this load will end in blocking some of the calls. So let me go here back to my API management instance. Let us quickly go to so this is this management plane essentially that allows us to centrally manage the operations, yeah. And if I go here into this view, I see that I've essentially applying on all of the operations. So I've exposed two operations here through the API management gateway. The first one is the actual token endpoint that is the one that is responsible for retrieving the SAML assertion from Azure AD and exchanging it with the OAuth access token from the backend system. And the second operation is the actual product catalog search operation. On all of these operations, I'm enforcing a rate limit. Yeah, so a real simple policy here. But as you can see, I'm rating here the limit to 20 calls. Yeah. So now you might think, okay, if I hit the gateway now with my 20 calls in the in this load testing tool, I should have no problem because 20 is allowed. However, that number here for the on-prem for this self-hosted gateway has always been divided by 2. So essentially, you are enforcing here a limit of 10 because the self-hosted gateway is deployed with like a replica of 2 instances. So this number that you specify here is actually shared between those 2 instances deployed with the self-hosted gateway. So you are actually enforced. So this is something you have to know. So you are actually enforcing here a rate limit of 10. Yeah, with that. Maybe this is something that will change. By the way, we are looking here at still at a preview feature. Will correct me if I'm wrong here, but I think the self-hosted gateway deployment on an on-prem Arc-enabled Kubernetes cluster is still in a preview phase.
Preview feature, yeah.
Yeah. So maybe this will be a little bit that will change. I don't know. But let us now start that load test.
What's worth but just being clear on as well, though, is that the self-hosted gateway itself is not in preview anymore.
Yeah. Right.
But the feature to deploy it on an Arc-enabled Kubernetes cluster is
exactly. It's just that feature that this deployment option. Exactly. Yeah. Thanks, Will. Yeah. Exactly. Okay. Let's start the test. And I'm seeing only rejections. That is something I hope not to see. Let me see. Okay. Yeah. Sure. Okay. I haven't replaced the access token. That's right. So let me replace the access token with the one that's the step I forgot. I now need to copy paste because this access token should still be valid. Typically, the SAP system issues tokens that are, I mean, you can also influence that on the backend system, the lifetime of the tokens, but typically those are valid for an hour. So we should still be fine by setting this, by using this access token. So let's go back here. Let's clear quickly. Let's clear the log viewer here. Where was this clear operation? I would like to clear it.
On the run, I think.
Yeah, there was a
at the bottom.
Options. No, tools. Okay, let's start it just again. We will see that hopefully. Okay, so the new run now shows that the first 10 calls were successful. Yeah, so we got back a response data that should contain a response body that should contain. Okay, actually, there are no results. Okay, maybe that is due to the fact that I'm not authorized to look at this product catalog. Okay, that's also possible. But you see that in the end, 200 was responded, but the 11th call was blocked now by the API management with a status code 429 that essentially says the rate limit is now exceeded. And it gives us the nice information that we should try again in 60 seconds, because what we did here, a very polite answer, that we have a renewal period of this policy here of 60, which essentially says like after 60 seconds, that rate limit is set back to 0, yeah, and enforced again, yeah. In parallel, we have also now triggered on that API gateway an alert rule that should have been kicked now in due to the fact that we saw like an unusual, let's say, overload situation. Yeah, and let's go into Azure Monitor here and see how the integration between now this Arc-enabled infrastructure and Azure Monitor looks like. So if I go here to my alerts, I can see that there are warnings. And as you can see just recently, yeah, that was like, that should be the alert message that we just saw fully. Yeah, we saw that there has been an API overload message sent due to the fact that there was a high number, an unusual high number of requests that hit the API management here. Yeah, so and due to the fact that we set that limit here to also, I think, higher than 10, an alert message or an alert has been generated, which then has, for example, here triggered an email that was sent out to the administrator of that subscription or to some operator, yeah, in order to inform that there has been an unusual situation, yeah, occurred. And yeah. So, and with that, I think, and let me also quickly go back here to my chatbot and see if, okay, here
return the data.
Hey,
Perfect.
here we get the, okay, I would be really disappointed if that hasn't worked, but forgive me for, I mean, I'm running here with Teams and video on, and my machine is a little bit overloaded at the moment, but it's still, we still got an answer back here. So,
cool.
All right. Yeah, and with that, I'm almost done with my presentation. I think, yeah, so just to mention that if you really want to go yourself through this end-to-end scenario from the early beginnings of using just a very simple client, not a Teams chatbot, but just a more or less like a command line client that integrates with SAP BTP and invokes a service there. And then, you know, the scenario grows from part to part of my blog series. And now finally we got in part 5 exactly to the scenario that we looked at today in this podcast, where we essentially made the scenario a little bit more production ready. I'm not saying that all of that there's much more to take care for production level setup, but I think API management and also Azure Arc here with all the integration with the known services in Azure, such as Monitor, such as Defender, such as Azure Policy, you are getting much closer to a production level setup of this scenario. All right.
Great.
Cool. I think that's really fantastic, and it's great to see how the scenario that you started evolves and evolves and evolves, and it's getting bigger and bigger and more complex, but also I think more relevant to the customers, to real productive scenarios. So I think that's really fantastic.
Right. And I mean, and Holger, this is all driven by customer demand. Yeah. So I mean, it's nothing that actually, let's say, well, we've invented, but I mean, customers are actively asking for ask these questions. Yeah. And that's the reason why, this scenario is growing and growing. Yeah. All right.
Great. Then I think that's a perfect closing. I mean, we have the full end-to-end story. We saw how Azure Arc works, how you introduced API management. I think what we definitely want to do as one of the follow-ups, and I think you have this also in your blog post, is that right now, as we've seen, the authentication is done in the Power Automate flow, where you have the token exchange, and then you have finally the right access token to call the OData service. But this authentication flow could also be done in the API management. You have done a lot of work also with Martin Pankraz on creating this policy for the API management. And I think we'll definitely have another podcast, another follow-up on this, where we take a closer look at how the policy for the API management works.
Yeah, I'd love to. I think come back and chat about that. The length and scope of the things that you can do in APIM to apply security and management for those APIs as well goes obviously far beyond the context we could drop in a short session. But just the examples that Martin's given there are really a really good sample of the things that you can pick out. We could go through some of those on a subsequent session as part of the integrated principal propagation as well, if you like.
We'll definitely do this, Will. So we'll work on some times, and then you'll join us on one of the next shows.
Great.
Cool. With this, thank you. I think again a more lengthy episode, but I think it's always fantastic to really see how you're guiding us through the whole process step by step. So Martin, thank you very much for all the work, for the great introduction, for the great demo. And latest with part 6 or 7. We'll see you again.
Always a pleasure, guys.
Great.
Thank you very much.
Thank you, everyone. Have a nice day.
Bye-bye.
Bye-bye.